Hello, you should see that now from my list that I've completed my decay, and we've gone to 14 rolls. So by 14 rolls, we went 13, we had one left, 14, we had one left, and I thought rather than just keep going, I'm going to stop there with one. Because it could be that you do this a number of times and you end up with just one sweet left over and over and over again, because it always lands M side down or S side down. That's absolutely fine. So you only roll the remaining sweets with the letter facing down, and eventually you keep going until there's none left, or until you've consistently got one. Now, what you then do is you would plot these numbers on a graph, and the graph should, let me just sort my paper out, the graph should look like this. Obviously, I'm sketching this really, really basic. So this is a roll number along here. So obviously starting at 0 and it'd be finishing at 14. And then other side, it'd be undecayed sweets. Now, obviously, they're not decaying, but we would, for argument's sake, say that they were decaying. And what you'd find is that the graph does a nice steep curve like that right down. And this here might not go exactly to 0, and that's absolutely fine. It might just keep going. It might just go down to 1, like mine's gone to 1 twice. So that's what it would look like. And again, it might be that you've got dots like either side here. That's fine. But what you would do, line of best fit, just remember in science it can be a curve. So a line of best fit does not have to be a straight line. It can be a curve as well. Okay, so in the next part of the video, I will be showing you what the half-life of this would be and how you'd work that out from the graph. So hopefully that was a nice little informative way to show you the practical, and you can have a little go yourselves. I'm going to go and not eat all of these M&Ms now, but inevitably have a few of them. So yeah, hope that was a good example, and hope you've managed to get yourself a bag of something to have a go with this. But yeah, there's your modelling nuclear decay.